Good morning. I'm Devasena. In this lecture, we are going to discuss about the transformer equivalent resistance. This topic is present in the subject Electrical and Instrumentation Engineering. Let us start discussing the topic. Effect of winding resistance. A practical transformer windings possesses some resistance which not only cause the power losses but also the voltage drops. Let us see what is the effect of winding resistance on the performance of the transformer. Let R1 is equal to primary winding resistance in ohms, R2 is equal to secondary winding resistance in ohms. Now, when current I1 flows through primary, there is a voltage drop I1 R1 across the winding. The supply voltage V1 has to supply this drop. Hence, primary induced e.m.f. E1 is the vector difference between V1 and I1 R1. That is, E1 vector is equal to V1 vector minus I1 R1 vector. Consider this as equation 1. Similarly, the induced EMF in secondary is E2. When load is connected, current I2 flows. There is a voltage drop I2 R2. The EMF E2 has to supply this drop. The vector difference between E2 and I2 R2 is available to the load as a terminal voltage V2. That is, V2 vector is equal to E2 vector minus I2 R2 vector. Consider this as equation 2. The drops I1 R1 and I2 R2 are purely resistive drops, hence are always in phase with the respective currents I1 and I2. Equivalent resistance. The resistance of two windings R1 and R2 can be transferred to any one side, either primary or secondary, without affecting the performance of the transformer. The transformer of the resistance on any one side is advantageous as it makes the calculations very easy. The total copper loss due to both the resistance can be obtained as total copper loss is equal to I1 square R1 plus I2 square R2. That is equal to I1 square open bracket R1 plus I2 square by I1 square R2. That is total copper loss is equal to I1 square open bracket R1 plus 1 by K square R2. Consider this as equation 3, where I3 by I2 by I1 is equal to 1 by K, that is equal to neglecting no load current. Now equation 3 indicates that the total copper loss can be expressed as open bracket I1 square R1 plus I1 square R2 by K square. This means that R2 by K square is the resistance value of R2 shifted to primary side, which causes some copper loss with I1. As this value, it is denoted as R2 dash. R2 dash is equal to R2 by K square. Consider this as equation 4. Hence, the total resistance referred to primary is the addition of R1 and R2 dash, called equivalent resistance of the transformer referred to primary and denoted as R1E. That is R1E is equal to R1 plus R2 dash. That is equal to R1 plus R2 by K square. We'll consider this as equation 5. The resistance R1E causes some copper loss with I1 as the total loss due to the individual windings. Total copper loss is equal to I1 square R1E. That is I1 square R1E can be I1 square R1 plus I2 square R2. Consider this as equation 6. So equivalent resistance R1E simplifies the calculations as we have to calculate parameters on one side only. Here is the representation of the equivalent resistance referred to primary. That is R1E is the sum of R1 plus R2 dash. It is represented in the diagram. Similarly, it is possible to refer the equivalent resistance to secondary winding. Total copper loss is equal to I1 square R1 plus I2 square R2. If we take I2 square as common means I2 square open bracket I1 square by I2 square R1 plus R2. That is I2 square open bracket K square R1 plus R2. Consider this as equation 7. Thus, the resistance K square R1 is a primary resistance referred to secondary denoted as R1 dash. Therefore, R1 dash is equal to K square R1. Consider this as equation 8. Hence, the total resistance referred to secondary is the addition of R2 and R1 dash called equivalent resistance of transformer referred to secondary and denoted as R2E. Therefore, R2E is equal to R2 plus R1 dash. That is R2E is equal to R2 plus K square R1. Consider this as equation 9. Therefore, total copper loss is equal to I2 square R2E. Consider this as equation 10. Here is the representation of equivalent resistance referred to secondary. When a resistance are transferred to primary, the secondary winding becomes zero resistance winding for calculations purpose. The entire copper loss occurs due to R1E. Similarly, when resistance are referred to secondary, the primary becomes resistanceless for calculation purpose. The entire copper loss occurs due to R2E. When a resistance is to be transferred from primary to secondary, it must be multiplied by K square. When a resistance is to be transferred from secondary to primary, it must be divided by K square. Remember that the value of K is N2 by N1. That is secondary winding turns N2 divided by primary winding turns N1. R2 is shifted from secondary winding side to primary winding side. In this diagram, in the primary winding side we have R1 resistance. In the secondary winding side we have resistance R2. Now the resistance R2 in the secondary winding side has to be transferred to primary winding side. This is indicated here. So the equivalent resistance in the primary is R1E. This is equal to R1 plus R2 dash. R1 is shifted from primary winding side to secondary winding side. In this diagram, in the primary side we have R1 resistance, in the secondary side we have R2 resistance. Now we are going to shift the resistance R1 from the primary winding side to the secondary winding side. So in the secondary winding side the equivalent resistance is R2E. This is equal to R1 dash plus R2. Thank you very much for listening this lecture. If you like this lecture means, kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.